Good morning, students. Electrostatics for Neet and JEE. Next topic is equilibrium of charges. Yes, equilibrium of charges means if you are given one charge or if you are given system of charge particles, then what is equilibrium and types of equilibrium that we will see. See, first of all, for one charge, a charge is said to be in equilibrium if net force acting on is zero. Simple. Okay. A charge is said to be in equilibrium if net force acting on it is zero. For system of particles, system of charge particles is said to be in equilibrium if each charge particle is in equilibrium. So yes, whenever you are given system of charges, you have to find forces acting on each charge. If you are given three charges, then find resultant force acting on first charge, resultant force acting on second charge, resultant force acting on third charge. And if force acting on three charge particle is zero, then the system is said to be in equilibrium. But for system of charge particles, there are three types of equilibrium. Okay, first one is stable equilibrium. Now, what is meaning of stable equilibrium? Okay, if one charge is displaced from its mean position, okay, after displacing one charge, one charge from its mean position, if it returns or if it comes back to its mean position, okay, if you are given system of charges, find forces on each and every charge particles, and if force acting on each particle is zero, then yes, it is in stable equilibrium. But now, if you displace any one charge from its mean position, and if it comes back to its mean position, then it is called stable equilibrium. In case of stable equilibrium, potential energy U is minimum. And yes, du upon dx is equal to 0, but d square u upon d square x is positive. Clear? So these points you have to remember. Okay, if after displacing one charge from its mean position, if it comes back to its mean position, then it is called stable equilibrium. Now next, unstable equilibrium. Second, unstable equilibrium. Now what is meaning of unstable equilibrium? Similarly, like this. After displacing one charge from its mean position, if it comes back to mean position, then it is stable. And if does not come back to its mean position, it is called unstable equilibrium. Okay, if it never returns, see how to write after displacing, displacing one charge, after displacing one charge from its mean position, if it never returns, to its original position, it is called unstable. Equilibrium. Simple. And yes, for this unstable equilibrium, potential energy U is maximum. Du upon dx is 0, and d square U upon dx square is negative. Clear about this? So yes, these 2 points you have to remember. Next, third, what is neutral equilibrium? What is neutral equilibrium? In this case, after displacing from mean position, it returns to its original position. Here it will never return its original position, but if in this case, what is meaning of neutral equilibrium? After displacing one charge from its mean position, if it neither return nor move away, means it is stable at its position, it does not change its position, then it is called neutral equilibrium. Clear about this? Okay, if after displacing one charge from its mean position, it neither return nor move away. Okay, but remains in same position. Then this state is called neutral equilibrium. And in this case of neutral equilibrium, that U is constant, therefore du upon dx is equal to 0. As U is constant, du upon dx, the square U upon dx, the square U upon dx square is equal to, it is 0. Clear? So yes, these points you have to remember. Clear about this? Okay, so it is just theory purpose, but that you have to remember. Now we will see one question based on it. See, you are given point charges plus 4q minus q and plus 4q are kept on x-axis at points x is equal to 0, x is equal to a, and x is equal to 2a. Then you are given options. Yes, you are given options for in which equilibrium this system is. First of all, I will draw figure. X-axis O, x is equal to 0, x is equal to a, and here is x is equal to 2a. Here is plus 4q charge, here is minus q charge, and here is plus 4q charge. Okay, so first of all, we have to find forces acting on each charge. First of all, force acting on plus 4q charge. Force acting on plus 4q charge. Okay, force acting on plus 4q charge at x is equal to 0. The most simple question. Okay, force acting on this plus 4q charge, it is due to minus q charge and it is due to plus 4q charge. Yes or no? Yes. How to find these forces? So yes, see, force due to this plus 4q charge, it will be repulsive in this direction, and force due to this minus q charge, it will be attractive. in this direction. So yes, they both are in opposite direction. They both are in opposite direction. Yes or no? Yes it is. Yes or no? Yes it is. So force acting on plus 4q charge at x is equal to 0. F is equal to it is due to this 4q charge. So it is K 4q upon what is distance between these two 4q charges? It is 2a. Means it is 2a. Or I can directly write it is 4a square. So 4 cut is equal to it is. Okay. Okay. So it is force acting on this 4q due to this q. Now due to this minus q charge. Now due to this minus q charge, as it is in opposite direction, I will write minus sign. So it is K 4q. Its charge is q and distance is here it is a square. From figure it is clear. See, kq upon a square is square. So it is equal to 0. So what is resultant force acting on this 4q charge? It is 0. Now for this minus q charge, see, for this minus q charge it is easy. Two sides, 2 plus 4q charges at same distance. So again, force acting on minus q charge at x is equal to a is also 0. And similarly, from symmetry of figure, I can say force acting on this plus 4q charge is also 0. If force acting on plus 4q charge at x is equal to 2a is also 0. Yes or no? Because see, symmetry of figure. Okay, so yes, forces acting on each and every charge is 0. Yes or no? Means the system of charges in equilibrium. Now in which equilibrium? Stable equilibrium, unstable equilibrium, or neutral equilibrium, So for that, what I have to do, I will move any one charge. Suppose I move this 4q charge. Towards this direction. So see, from figure it is clear. This 2a distance will change. The distance a will also change. So distances will change, and due to that, resultant force acting on it also will change. And due to that, it will move in direction of force acting. Yes or no? Yes it is. Here, as distances are, it is distance A, that's why the resultant force is 0. Now, if you take another distance, force is not 0. Okay, if any one charge is displaced, from equilibrium condition, it will never return to its mean position. Therefore, system is in unstable equilibrium. Yes? Okay, if you displace any one charge, it will never return to its original condition. Because see, if I decrease this distance, yes or no? Yes. Then what happens? Force due to this minus q charge, as distance decreases, force increases. Force due to this minus q charge will increase, and this charge particle is then accelerated, or it will move towards that minus q charge. Clear about this? So yes, it is unstable equilibrium. Okay, now we will see next case. Next question: if an insulated non-conducting sphere of radius r has charge density rho, the electric field at distance r from the center of sphere where r is less than r. See, what is difference between non-conducting sphere and conducting sphere? Conducting sphere, charge is only on its surface. Inside conductor, charge is 0. Simple. While in case of non-conducting sphere, suppose it is non-conducting sphere and let it is positively charged, for example. Okay. Then charge is inside everywhere, uniformly distributed. Uniformly distributed. Clear? So it is difference between non-conducting sphere and conducting sphere. Yes, its radius is r. Its radius is r. But we have to find electric field at distance small r less than r. So suppose I want to find electric field at this distance, at this point, having distance r. So yes, we know how to find electric field with the help of Gauss law. So I have to assume one Gaussian surface having radius r. I have to assume one Gaussian surface. It is Gaussian surface. Okay. So what is Gauss law? It is integration E dot d is equal to sigma q upon epsilon 0. We know what is answer of integration E dot d. Okay. It is E 4 pi r square. But what about sigma q, charge enclosed by Gaussian surface? See, you are given charge density. So for this whole sphere, okay, for this whole sphere, I can write okay, rho is equal to it is if charge on it is q. Okay, and here it is 4 by 3 pi r. So it is rho. Yes or no? Or you are given directly rho, so you can write directly. What is radius of this sphere? It is small r. What is radius of this sphere? It is small r. So what is its volume? It is 4 by 3 pi r cube. So what is charge? It is rho dV upon epsilon 0. Simple. So E 4 pi r square rho dV means volume of this Gaussian surface. It is 4 by 3 pi r cube divided by epsilon 0. Simple? Yes. So 4 pi cut. Okay, r square. Here it is r. So electric field E is equal to rho r upon 3 epsilon 0. E is equal to rho r upon 3 epsilon 0. That you have to remember. Yes, this equation you have to remember. For non-conducting sphere of radius r, what is electric field inside? E is equal to rho r upon 3 epsilon 0. E is equal to rho r upon 3 epsilon 0. Clear? Clear? Okay. If you are asked outside, okay, if r is greater than r, then for this r is greater than r, it is easy. See, again, it is integration E dot dA is equal to sigma q upon epsilon 0. It is E 4 pi r square sigma q. If point is outside, then the charge on this whole non-conducting sphere is inside Gaussian surface. So in that case, how to write equation? Yes, equation is q upon epsilon 0. Okay. So yes, what is E? E is equal to 1 upon 4 pi epsilon 0. It is q upon r square. Clear? And yes, this equation you already know. Clear about this? Yes or no? Yes, it is. Okay. I can also write this equation as, if I want to put value of rho, then if I put value of rho, it is q r upon 3 epsilon 0. What is value of rho? It is 4 by 3 pi r. So yes, this 3 cut. So is equal to it is 1 upon 4 pi epsilon 0 q r upon r. Simple? Yes. Yes, if I want to find what is electric field on surface. Now on surface, simple. I have to put small r is equal to capital R. If you put in this equation small r is equal to capital R, you will get 1 upon 4 pi epsilon 0 q upon r square. Also in this equation. So yes, on surface, electric field E is equal to it is 1 upon 4 pi epsilon 0 q upon r square. Simple. Clear? So yes, this one extra case that you have to remember for equations. Okay. Now next question. See, next question. You are given 3 infinite plane sheet having surface charge density sigma, -2 sigma and -sigma. and z is equal to minus a, z is equal to a, and z is equal to 3a. You have to find what is electric field at point P. See, you know that due to infinite plane shift, what is equation of electric field? If I have positive plate, then electric field outside E is equal to sigma upon 2 epsilon 0. If I have negative plate, then electric field is inside and it is E is equal to sigma upon 2 epsilon 0. Clear? Yes. So yes, we have to find electric field at point P. See in this equation, it depends only on sigma, that is surface charge density. It does not depend on distance. So no matter z is equal to 3a, z is equal to a, or z is equal to minus a. Clear about this? Okay. First of all, let me name this figure. It is first plate, second plate, and it is third plate. So due to this first plate, electric field at point P, as it is negative plate, due to negative plate, electric field is towards. So E1, it is in this direction. Simple. Yes or no? Yes, it is. Second plate, it is also negative. So due to negative charge, electric field is again towards, means E2. It is also in this direction. So yes, it is E2. Yes or no? Yes. Due to third plate, which is positive, and due to positive at point P, it is away. Away means in this direction. So yes, it is E3. So E1, E2, and E3, they are in same direction. E1, E2, and E3, they are in same direction. So resultant electric field E is equal to, it is E1 plus E2 plus E3 is equal to E1, its surface charge density is sigma upon 2 epsilon 0 plus it is 2 sigma upon 2 epsilon 0 plus it is sigma upon 2 epsilon 0. So yes, 2, 3 and 4. So it is 4 sigma upon 2 epsilon 0 means it is 2 sigma upon epsilon 0. It is your answer. It is your answer. And in which direction? So yes, z is equal to a, z is equal to 3a means it is positive z direction. While it is negative z direction, so it is in negative z direction. In negative z direction. Clear? Yes or no? Yes. So see, this plus, minus and minus, we already have used in direction. Okay. So here I have to write only its magnitude. Clear about this? So here is one question which is based on again electric field. For today, this is it.